Chemical Computer Applications, CHM 503. This is lecture number 1, and we're in chapter 1, and we're going to take you through the requirements of this course. On the second page is a list of all of the topics that are covered in these notes. So chapter 1 is simply an explanation of the assignments in the course. Chapter 2 is a very short chapter related to web searching, and there's a short assignment related to it which I will explain to you shortly. Chapters 3 and 4, Biorad Know-It-All and ACD Chem Sketch. These are two chemistry drawing softwares that are free. The website addresses where you can download these are listed on the syllabus, but you could simply just Google freeware Biorad Know-It-All or freeware ACD Chem Sketch and you'll find them right away. Now I have instructions, written instructions for both, and I also have a video for each in the range of 30 to 40 minutes each. You will not be evaluated on your skill in using either of these softwares, but you'll want to learn to use the software to make professional looking lab reports, including mechanisms and structures and glassware. Now, by way of comparing the two, it's difficult to say which is better. They both have advantages and disadvantages. Most students say that they pick up Know-It-All quicker, at least I've seen that. It takes a little bit longer to learn Chem Sketch. With Know-It-All, you're actually typing in the element symbols, either the actual symbols themselves or hotkeys for them, and then you're drawing bonds with the mouse. So you're back and forth between mouse and keyboard, and that slows you down. ACD Chem Sketch, although it takes perhaps an extra hour or two to learn, it's all mouse driven. Most of it, 90% of it, is on the mouse, and so it's quicker by not switching between the two. Another thing to consider is that both Biorad Know-It-All and ACD Chem Sketch require that you have a current St. Clair College student number. You can download either of them, but when you go to use them, you're asked to enter your college student number, and once you do that, it'll give you an activation key and you can use it. The difference is that with Biorad, the license is only for 1 year. So at the end of a year, it's no longer active. You have to then enter another active St. Clair College student number to use it for another year. And if when you graduate, well, then you're out of luck. With ACD Chem Sketch, once you activate it, it works forever. So you'll always have it as long as you keep that laptop or PC. They're excellent pieces of software. If you had to buy them on the free market, you'd be paying probably close to $1,000 each, so it's a great deal. Chapter 5 is PowerPoint. There's a set of notes on using PowerPoint. Now, the advisory committee for our department made it very clear some years back that they do not want us to spend time teaching PowerPoint because most students coming out of high school have a pretty good handle on it already. You do have an assignment in PowerPoint, and I do have instructions for using it, and I have a short video clip to show you some of the functionalities I want you to include in your PowerPoint project. Chapter 6 is Microsoft Word for Technology. In technology, we use a lot of special characters, and there is quite a number available to you in Word that you probably are not completely familiar with, and I'm going to show you those. Also, using Microsoft Word for formatting documents professionally is very important, and we have an assignment related to that. I will explain. Chapter 7, 8, 9, 10, 11, 12, 13, and 14 are all about Excel. Now 10 includes both Excel and the Sharp calculator. That's the bulk of our course. Chapter 15, using Microsoft Access to create a chemical database. Unfortunately, because we have a reduced semester length this year, I have to eliminate something, and that's what's going to be eliminated. The next page is a summary of the calculators that are supported and recommended by the chemistry department. So the Sharp electronic calculators are reasonably powerful and reasonably priced. The 520, 546, and 516 series calculators have more than enough functionality to do everything we're going to do in this program. Of the batch, this most current one, the ELW 516XG, is by far the easiest to use. It's an extra $15 or so. You can decide whether you want to spend that for it. Any of the calculators that have the W prefix are described as being right for you. So they have an extra couple of lines for text entry, and they're actually much easier to use, particularly for differentials and integrations. You don't necessarily have to rush into buying one right now. You can wait and see when we get to chapter 10. At that time, if you're finding it awkward to use one of the earlier models, you might consider purchasing the up-to-date model. On the next page, we have a brief summary of the 3 assignments that are due in this course. So in week 3, you have a web assignment. It's worth 2% of your final mark, and you're going to submit that in the assignment center in Blackboard, even though it says by email. Submit it there. Make sure that whatever submissions you send, that you include your name in the file name. So if your name was Joe Smart, it would be Joe Smart, then the web assignment, and then the date. If we leave the name out, you lose a mark. So the web assignment I'll show you in just a moment. It's just a single sheet of paper. Write a summary of 2 different chemical websites that you have researched, and type it in. It's informal, but it still requires full sentences with grammar and spelling, but informal. MS Word. Each website will include the following descriptions. Include the website address, because I will visit it. I want to see what you're describing, and actually over the years I've seen some pretty neat websites that students have directed me to. Secondly, a brief description of the site content. And it must be in your own words. Don't just copy and paste what it says on the website, because I will visit it. Don't make it formal and fancy. Just state in very plain words what the website is telling you about. And thirdly, what's the potential usefulness? It doesn't have to be the greatest website, but it might have some potential usefulness, so describe that to me. So D, paste a small graphic obtained from the website by some screen capture method, and we'll look at that shortly. There's a 10% bonus for each unique website that no other student has described. So the first year I gave this assignment, I was very disappointed to find that half the class gave me exactly the same websites. So they really weren't interested at all in the process of learning. They were more interested in the marks, and as a teacher that's always a little discouraging, but so I've changed that. So you get 10% bonus, 10% of 2% for each website that is unique and no other student has described. Let's take a look at a web assignment. Here's a sample, very simple, single page, 2 websites. The student chose the NIST website. There's the URL, described it in a sentence or 2, what it might be useful for, and pasted a graphic. And here's the second one. And in this case, no other student had described this particular website, so the student got a bonus. 2% of 2 is 0.2. They got 2.2 out of 2. But the student lost 0.2% because he didn't put his name on the page. All right, so that's the web assignment. The second assignment is a Microsoft Word assignment. This is worth 10% of your final grade. It's due in week 10. So it'll be an MS Word document. Again, you're going to include your file name and the name of the assignment and the date. And for this one, choose a chemical industry. And I have a list for you to choose from. I'll talk about it in just a minute. Spelling and grammar are marked. Most importantly, this must follow the format of a technical paper. It has to be formal. We use the American Chemical Society format for writing papers in chemistry. Your paper must contain all of the elements listed on the evaluation sheet. Now, before we take a look at that, I just want to describe the last assignment, and we'll look at these in more detail. The third assignment, worth 8% of your final mark, due in week 7, is a Microsoft PowerPoint assignment. So for that one, you're going to evaluate a career of your choice that must be in chemistry. The Ministry of Education has asked us to do this. They want you to consider the career you're thinking of entering. Our next page simply lists our assignments and tests, the weeks in which they are due, and the exact dates are posted on the syllabus and the master schedule, which is at the top of the list in the course documents section. Please note that late assignments are penalized 15% per school day, so try to get them in on time. This next page describes the requirements of the MS Word assignment, the formal report. And here's how I will evaluate it, so make sure that all of these are included. Many times students give me very nice reports, but have left out a number of these items and they lose considerable marks for it. So just be careful before you hand it in. Go through this and make sure you've included all of these. This is a computer course, and I'm more interested in whether you've learned how to format a report properly than in the content per se. The content is not of great importance to me in this particular assignment. So as far as formatting goes, I'll run through some of these briefly. You start with a front flyleaf. What's that? That's a blank page. What for? To protect the document. Page 1 of the document is a letter of transmittal. Needs to be signed. Page 2 is a title page. Page 3 is a synopsis. A synopsis is a summary, usually a paragraph long. What for? So the researcher doesn't want to have to read the entire paper to decide if it's suitable for what he or she is looking for. The synopsis should tell the reader what has been researched and what has been found, so it can easily be evaluated whether it's suitable or not. Notice that's page 3 in Roman numerals. Then follow the tables. We have a table of contents, table of figures, table of tables, table of equations, and there's a format for doing these, and I'll show you. Then we have the introduction, which is actually chapter 1. You notice how the pagination changes. We go from page 7 Roman numerals to page 1 Arabic numerals. You do that with section breaks, and I'll show you how to do that. There's a video for it. Then we have margins. Now, on every page, the left margin is always 1.5 inches. The right margin is always 1 inch. The bottom margin is always 1 inch. The top margin changes. The top margin is 1.5 inches if it's the first page of a new section. For example, every one of these thus far is a new section. They all would have a 1.5 inch top margin. But once you get into the first chapter, then you have multiple pages in the same chapter. And then the second and all subsequent pages in that chapter would have a 1 inch top margin instead of a 1.5 inch top margin. Headings, just pay close attention to the requirements for the headings and subheadings. Notice that the typing must all be size 12 point font. Times New Roman or Palantino linotype or something very similar to that. We're not allowed to make a pretty document. This is not about appearances. In fact, when you read technical literature, it's anything but attractive. So you can't decide that you're going to make flowery letters or large letters or small letters. There is a format for technical papers that every paper must follow, and that's what you're going to be marked on here. It'll be double-spaced, single-sided. I'll talk about pagination in a bit. Figures are labeled below the figure. We use Arabic numeration, typical Canadian numeration, lowercase, not bold. Tables use uppercase Roman numeral numeration centered above the figure and in lowercase, again not bold. So very specific formatting that you need to pay attention to. Citations and bibliographies. One of the most annoying parts of a paper, but Microsoft Word has a wonderful way of simplifying that and printing it for us, and that is explained in a video that you can watch as well as in the notes. The rear flyleaf is a blank sheet. Every paper must include a chemical structure labeled as a figure, an equation, at least one, and pagination, as I will discuss, as well as an appendix. So your document must include all the elements listed above. It must include at least one section that is longer than one page to show the changes in page number, positioning, and the margins. Just a word of caution, never split a table across 2 pages. Try to make it fit on a single page. But you still have to retain a size 12 point font. So if that's a challenge, then you put the table to fill an entire page, perhaps in the appendix. If it has to split over more than one page, then make sure you copy all of the labels, the headings on each page. Now, you can't copy my examples from the notes. Sometimes ask me, can I just copy your examples? No, I'll take the marks if you do that. Make sure you do your own figures and tables and bibliography. Now, I will measure your margins, make sure they are the right size. Submit a digital copy and include your file name along with the name of the assignment. Here I have described in sentence form the requirements of a formal report. For example, the first and last pages are flyleaves, blank pages. The second page is a letter of transmittal. It's page 1, but this is not printed on the page. The third page, and so on. Here's an example of an equation that's formatted properly. Equation number on the right. Here is a figure. A figure is a picture, it's a graph, and we have it, the caption is centered below the figure. Lowercase, not bolded, Arabic numeration. Here's a table. Tables are labeled above the table. Lowercase, not bolded. Uppercase Roman numeral, numeration. Here is how to cite and give references to your work. Bibliographies, most tedious to do, but in Microsoft Word, it's a dream. It makes it really easy to do, and I have a short video that shows you how to collect all of your citations, and Microsoft Word will create the bibliography for you in proper format. Here in the notes is an example. My first page is a flyleaf, a blank page. Here is the letter of transmittal. That's actually page 1. Notice it's signed. In your case, you'll probably just have to use a italic font since you're not handing in a piece of paper this year. After the letter of transmittal is the title page. Notice the title page is not pretty. Don't try and make it pretty. Just follow the conventions. Note where it's underlined, where it's uppercase, where it's lowercase, where it's bolded, where it's not bolded. That's page 2, and finally page 3 is the synopsis, but notice page 2 is not numbered, nor is page 1. Page 3, the synopsis, is numbered at the bottom, center, lowercase Roman numeral. How do you do that? With section breaks, and I have a video to show you how to do that. The synopsis is a paragraph or so describing what you found in your report. After the synopsis comes your tables. Table of contents. Now notice that the first page in each section has a 1.5 inch top margin. And then the title of that page is always in uppercase, centered. Then you leave a line below it. And then follows the rest of the page. In this case, it's the table of contents. Now, Microsoft Word will create this for you if you label all your titles. And I'll show you how to do that in a video. It's very easy, actually. That's page 4. Page 5 would be the table of figures. Notice again, the beginning of a new section, 1.5 inch top margin. The title is uppercase, centered, line below it, and then you have your list of your figures. Page 6 is the table of tables in similar format. Page 7 is a table of equations. Now, I haven't found a good system for automating this in Word, and so I just typed this in manually using the same format. After the table of tables, we finally start the body of the report, the introduction. Being the first page of a section, it has a 1.5 inch top margin. The title is in uppercase and centered. There's a full space below it. Here I have an equation, a figure, and notice the pagination. On the first page of each section, the page number is at the bottom center. But when you go to the second and all subsequent pages in a given chapter or given section, the page number moves from the bottom center to the top right. And furthermore, the top margin shrinks from 1.5 inches down to 1 inch. This is done with section breaks. Here's a table that is formatted properly, uppercase Roman numeral. The label is above the table. It is not bolded. It is lowercase. Here's the second chapter. Notice what happens in the next chapter. The pagination moves to the bottom center, and then on the subsequent pages in that chapter, it moves to the top right again. At the end of your chapters, you'll have an appendix for pictures, for charts, so include at least one appendix item, as I have here. Just pick a drawing if you want. You can take it from ChemSketch or Know-It-All. And finally, you'll have the bibliography. And again, if you enter your citations in the References tab in Word, it'll collect them all and print the bibliography for you. It's beautiful. Finally, that's followed by a rear flyleaf, a blank page. Recall that you're to pick a topic related to a chemical industry. I have this list of chemical industries posted on Blackboard for you under the Word Assignments section. So pick one of these. If there's something you really would rather do otherwise, just send me an email and we can discuss it. I'm pretty flexible on this. I'm really looking at format more than content again. But keep this in mind. In the 5th semester, you'll be doing the same preparation. You'll be doing a formal report on a chemical industry. It'll be one of these chemical industries. You'll be submitting a formal report and making a PowerPoint presentation of the class. So why not kill two birds with one stone? You can pick a project now and use that very same project next year in the 5th semester. We're looking at a different aspect in each case. Here we're looking at format, there we're looking at content. Now here is an example of a file made in the 5th semester last year by one of our students. It's a formal report. She's discussing glue obtained from animal hoofs and animal hides and such. Here's the flyleaf. Here is the letter of transmittal, signed. Here is the title page, properly formatted. Here's the synopsis. Notice page 3. The first page is numbered. Then we have our tables. Table of contents. Table of figures. Table of tables. Even though there's not many in there, you need to go through the process of including each of these tables. And table of equations. Then we get into the body of the report, the introduction. This is well written. First equation, properly labeled. Notice the citations in the body of the text, properly cited. And the pagination at the lower center. The second and all subsequent pages in that chapter, we move to the top right corner for pagination and the margin shrinks. We start the next chapter. Again, we have the 1.5 inch top margin, the title centered, uppercase followed by a blank space, and we continue on. Pagination moves to the bottom center, subsequent pages to the top right. Here's another figure that's properly formatted. Here's a new section, environmental effects. Just notice the spelling. It should be effects, not affects. Applications, and so on. I'll just skip through this. There's a table. Notice the caption is properly labeled in uppercase Roman numeral, and it's located above the table, not below like figures. Appendix. Bibliography, and rear flyleaf. So you can see this. I have this posted on Blackboard for you to compare. Let's go back to our assignments. Your third assignment is a PowerPoint project, and it's worth 8% of your final mark. 4% is based on having certain functional pieces that work in a certain way in a PowerPoint presentation, and 4% is based on the content. So here's the functionality. Here's the components I'm looking for. An embedded Excel graph, piece of cake, a table or from Excel or Word, a movie created in Bio-Rad Know-It-All. I'll show you that. It's something of a molecule rotating. Speaker notes on the first slide at least, a hidden slide somewhere in it, text dimming, hyperlinks, back, forward, and beginning on each page, numbered slides, text animation, at least one example of sound added to text, slide transitions, and an animated pie chart. Now, let's look at the functionality, and we'll come back and talk about the content. So here's a PowerPoint presentation that contains all of the functions that are listed in the marking scheme. The topic is not the same. This is a chemical industry. You'll be doing a career choice. The first slide is not usually numbered. Typically, you don't see a slide number here. The first slide usually has just the next and end buttons on it. Transitions and sound have been added. And most of these slides have speaker notes at the bottom. So this is slide number 2. Notice it's numbered. Slides should have 4 hyperlinks: first, previous, next, and last. Notice the slide transition. This slide has text animation, text dimming, and sound added to text. So there's text animation and sound added to text. Now what's happening here? These are necessary fundamentals for learning organic chemistry, and I'm listing them here. Notice that each one that comes up as a new color, and the previous ones fade out, if you will. This is called text dimming, and it helps the audience to focus on what the reader is reading. But it doesn't hide the previous material that we can refer back to when we want to. Formal charge, resonance, acid-base reaction mechanisms, balancing redox equations, nucleophiles and electrophiles, and polarizability. 10 essentials for learning organic chemistry. Alright, so here's the slide number, and I want you to include an animation of a molecule, and these can be created in Bio-Rad Know-It-All. There's a video to show you how. Take a look. This might be useful if you're doing a presentation describing a certain chemical that is perhaps an impurity, a contaminant. Maybe it's something you're adding to a cleaning agent. Anyway, it adds a nice touch. I'd like you to add sound, not necessarily this sound. Let me jump to Blackboard for just a moment here. In the Course Documents folder, at the top of the list we have the master schedule. Scroll down, you'll find a folder for PowerPoint files. In that folder is another folder for audio files. Earth MP3, Mars MP3, Mercury MP3. These are spacey kind of music that we often hear when we see molecules rotating on the television. You can use some of those, for example. So here's a table that's been added, and what we have here is an animated chart. So this animated chart is not animated because it's moving. It's animated because each piece comes in one at a time with each click. This would be useful in a presentation. Maybe this is a safety talk and you're looking at number of injuries, percentages of injuries. Maybe it's production. Whatever it happens to be, you can bring each piece in one at a time as you discuss it. Now, be aware that not all Excel charts can be animated piece by piece. There's only a few. Pie charts are one of them, so make sure you check before you try it out. Here's a chart that's been added. This is the last slide. The last slide will only have previous and first slides hyperlinks. Now the reason for the hyperlinks, you might think, well, these are redundant, we don't really need them, and you're right, but I just want you to see how to insert hyperlinks. You can insert a lot of things through hyperlinks, not just motion. Now, if we right-click on the slide and go to See All Slides, this is a slide sorter view. One of the slides, slide number 3, didn't appear, and you see it's crossed out. That's because it's a hidden slide. Let's click on it. Hidden slides contain information that you prepare in anticipation that you'll be asked questions, and you will be asked questions in your presentations, not for computer class, but for the later courses in the program. And so you need to prepare hidden slides and have your defense ready. So those are all the requirements of the PowerPoint presentation. Let's go back and take a look at the content requirement for the PowerPoint presentation. So the content of your PowerPoint project will be an evaluation of a career in chemistry of your choice. There'll be 8 aspects to consider. 1 slide for each, please. So you'll have a title slide and 8 more slides. The first slide, so state the duties, the activities of the person in the career, and also suggest a specific branch of chemistry where this career applies. Is it sales? Is it R&D? Is it academia? Environmental monitoring? Healthcare? Pollution control? Foods, cosmetics, plastics, paints, coatings, polymers, medical supplies, water treatment, and on and on and on. And you know, many times I've been at open houses and spoke to parents and spoke to students, and they'll ask me the question, what kinds of industries hire chem lab technologists? And you start listing them off, and it sounds like a machine. There's so many, you don't know where to stop. A better question would be, what industries do not have chem lab technologists? Because so many of them do. Number 2, educational requirements. It's great to want to be a forensic scientist and do crime scene investigation, but what education is required? So that's an important thing to consider. And then where do you get this training? Interests. What aspects of this career do or do not appeal to you? Now, for example, consider whether you prefer working with people, sales and service. Salespeople typically get a company car. They get an expense account to take people to lunch. They have to be good talkers and like people. Maybe you prefer instrumentation. Maybe you prefer process equipment and process production. It's usually higher pay but high stress. You need a skin like a rhinoceros, dealing with all the stresses of the job. How about the values? State if any of this work is gratifying. Now, you don't have to make stuff up. If you can honestly say, look, all I care about is the money, and that's my value, that's not wrong for this. And all I'm saying is what aspects of this job line up with your values. Here's some suggestions. Is it gratifying because it's environmental conservation, because it's water purification, because it's medical, perhaps teaching? Is it noble? What about roles? Does your job involve supervision, being in charge? Are you firstborn? Do you like giving orders? Do you like working independently? Or routine work that you don't have to take home and you can focus on your family? Will you be challenged and grow in your knowledge and expertise? Maybe you don't want that. These are not right and wrong answers per se. It's just I want you to think about how this type of job would affect what you really enjoy or don't like. How does the career line up with this? Skills and aptitudes. Reality is not all of us have the same skills and aptitudes. Does your job involve physically demanding activities such as lifting or climbing or working in a smelly environment, wearing uncomfortable personal protective equipment, hearing protection, rubber suits, face shields, respirators, and masks? Can you do it? Does it require shift work? Do you like shift work? Do you like working afternoons or night shifts? Can you handle that? Now, if you're a good sleeper, maybe that's good. If you're a bad sleeper, consider that. Now, if you do work shift work, you get weekends. Saturdays are time and a half, Sundays and holidays, double time. Young people really like that to pay off their car, pay off their mortgage. Is that desirable or undesirable to you? Is your work highly academic? Does it require precise coordination or dexterity? One of our graduates is working at a university now where they make all the medical isotopes, radioactive isotopes for Canada. That requires some dexterity. Does it require strong self-assurance to make hard decisions and the ability to discipline others in management's position? Preferred environments. Is your job outdoors? You're subjected to weather changes. Is your job local? Is it near family or friends, or must you travel far or frequently? Do you need to cross the border? We have a company in the States, in River Rouge, which is opposite Amherstburg, and we've had a lot of our grads go there hired right away, and they work there for a few years, and most of them quit after a few years. They just find, even though the pay is very good and the job is all right, they just find traveling across customs day after day is pretty difficult, and unless you choose to move there, it kind of wears on you. Does your job require working closely with others, or is it independent? Can you share your resources? How about your workspace? I go into some offices, they have these tiny wee cubicles next to each other, and they have this horrible elevator music on. I couldn't handle that personally, but you might be fine with that. Last but not least, tangible rewards. Discuss the pay, the benefits, the vacation. What about job flex time? What about maternity leave or paternity leave? What about perks? Company vehicle, expense account, club memberships. Now these usually come for managers' positions, but worth thinking about. Consider the size of the company. Bigger company gives you perhaps more job security, maybe more possibility of career advancement. On the other hand, in a small company, you often have more flexibility, you can do more things. So again, in your PowerPoint presentation, create one slide for each of the 8 points. Evaluate a career in chemistry with respect to each point. And discuss your plans with the instructor if you're not clear. And finally here, if you're looking for information on wages and benefits, so the U.S. Bureau of Labor Statistics website is helpful. It lists hourly wages, annual salaries, and the number of people employed in several thousand occupations in the USA. And that's pretty much it for the assignments described in Chapter 1.